All right, my Math 7 people, let's get started on inequality basics. So for this launch, we're going to write what each inequality symbol means, and then we're going to complete the chart with either the less than, greater than, less than or equal to, or greater than or equal to sign. So this first one, that first sign, this should come as no surprise. We know this is a less than symbol. And then the next one is the same thing, but only it is or equal to as well. So we're going to write less than or equal to. And then for the next sign, we have that means greater than. And then that last one is that same thing, so greater than. But then also because that line underneath, it is also or equal to. So we read this as that top one being a less than sign because some number is less than and then some other number after that. So for instance, in these phrases with the symbols, I kind of think of this as a number always goes prior to this and then always there's something at the end. So blank is greater than. So I always fill in numbers for this instance. So you could say like 4 is greater than 3 to make it a true statement. So with those numbers, I know that I would want to chomp that 4. But then you have to decide, is it or equal to? But because it says 4 is greater than, can 4 be greater than 4? So that's not a true statement, which means that it's only going to be chomping this 4. All right, and then same thing here, kind of again with blanks. So blank is no more than. So you would say like 2 is no more than 5. Obviously that's going to be 5 because if you put a 1 right there, 2 is no more than 1. That doesn't make any sense right there. So 2 is no more than 5 because that makes it a true statement. We know 5 again is greater, so I know that it's going to be chomping this way, but then you have to decide, is it or equal to? So 2 is no more than 5. So it could be 5 is no more than 5. If that's a true statement, which it is, I'm going to put that or equal to symbol underneath. All right, then the next one, blank is at least blank. Blank is at least blank. So 4 is at least 5, which is not a true statement. So 4 is at least 3. Therefore, it's a true statement. Could you also say 4 is at least 4? Yes, absolutely. So I'm going to chomp in this direction. And then just continue going. Blank is fewer than blank. So 7 is fewer than 3. 7 is fewer, nope, that's not a true statement, so I know that number needs to be bigger. So 7 is fewer than 9. Okay, we are good to go, so I know that that symbol needs to go in that direction. Blank exceeds blank. Exceeds is kind of the same word for is greater than. So blank is bigger than or is greater than. So 9 exceeds 10. Nope, that does not make sense. So I know that 9 exceeds like 8. So because 9 exceeds 8, I know that I want to chomp towards my 9. If it exceeds it, it means that it's greater than, like I said before. So it's going to be bigger. And then the last two, so blank is no less than. Blank is no less than. So 3 is no less than 2. Is 3 no less than 2? That's a true statement, right? So could 2 be no less than 2? That's still a very true statement. I'm going to chomp in this direction. And then finally, that last one, blank is at most. So blank is at most. We're just going to put in 2 numbers. So 3 is at most 2. 3 is at most 2. No, it's not at most 2 because it's bigger than it. So instead of using 2, let's try using like 4. So 3 is at most 4. That's a true statement. So I know that it could also be 4. So 4 is at most 4, or 3 is at most 3. And yes, that would be a true statement. So go ahead and keep these kind of symbols in mind because you're going to see these words kind of throughout the notes today and then also later on in chapter 6. Alrighty, so now we are going to write an inequality for each sentence, and be sure always for these that you are including a variable definition. So for example 1, it says Olivia sold more than 40 magazines. So she sold more than 40 magazines. I don't know how many Olivia sold, so that's going to be our X. So I would say X is the number of magazines. And I obviously do not have space here. Hopefully you have a little bit more space. And I always start with my X variable. And then I put a circle in here because that's what I'm trying to figure out, what inequality goes in that circle. And then I know that the other number that I'm looking at is the number 40. So this is where I always get started, because remember, your variable always has to be on the left side. So we have x and then some inequality, 40. So now we just need to identify the key phrase for our situation. So Olivia sold more than 40 magazines. So I know that more than is going to be my key phrase right there. I know I boxed it in, but circle either way. So if I want more than 40 magazines, just come up with other numbers that Olivia could sell. So could Olivia sell 38? Could she sell 10? Absolutely not, because you want to sell more than 40. So some other examples of the number of magazines Olivia sold could be like 50. She sold 100. So because those numbers are bigger than 40, I know that I'm going to chomp towards my variable. And then you always have to decide if it's or equal to. So could I sell 40 magazines? Well, no, Olivia has to sell more than 40, meaning that she could sell 41. So that's why it is not or equal to. All right, and then the next one, so you must be at least 18 to vote. Okay, so I know that X is going to be my voting age. That's what I don't know. So with our voting age, again, start with your X, and then we're going to use our big circle to include our inequality. And then the other number that we have is 18. So X is something 18, and now I'm going to identify my key phrase. So you must be at least 18 to vote. So if I'm at least 18, you could, again, come up with other numbers that would fit for our voting age. So could you be 16? Could you be 10? You could not. So because you want to be at least 18, you could be 19, you could be 20, you could be 67, you could be 28. It does not matter as long as that number is greater than 18. So again, because it's greater than 18, I know that I'm going to chomp my X. And could I be 18? Well, let's think about it. If you're at least 18, can you be 18 to vote? Absolutely. So we're also going to include that or equal to symbol. Sorry, that's so wonky. You can just go in that direction. All right, so go ahead and pause the video, and I want you to try for example 3. All right, so hopefully you define that variable as Patrick's age. He's no more than is what you circled because that is our key phrase. If I'm no more than 12, that means that you can be 12 or younger. So therefore your inequality needs to go in that direction. All right, so now we're going to complete this chart down below before we actually start graphing these. So in this chart, we have a symbol. We're going to identify if it's an open or closed dot, and then the direction that we're going to shade on the line. So if my symbol looks like this, I kind of treat this like it's an arrow, and so if it's a less than symbol, I know that essentially I'm going to shade in that direction, so I'm going to go ahead and start there. And then also, because it doesn't have a line underneath, I know that this is an open circle. So same thing right here, this is kind of like an arrow, so I'm shading in this direction. Now, this only works if the variable is on the left side, so variable on the left. If the variable is on the right, it's not going to be the case. So this only works if the variable's on the left side. So same thing right here. Oh, I need to tell you if that's open or closed. Again, that's still going to be very open because there's not an or equal to sign underneath, which means that I can't include that number that I'm starting at. All right, the next one, here's our arrow, so I know that I'm shading in this direction, and because this is an or equal to, this is going to be a closed dot on our graph. And then lastly, again, same direction this way. I know that this is also going to be a closed dot. So this is going to make a little bit more sense once we actually get to graphing. So let's go ahead and take a look down at example 4. Moving right along. So for example 4, it says we're going to graph the inequality on the number line. So your number line, it always has to include 3 numbers or 3 digits. So if you are listening to this video, somewhere near this example 4, I want you to write the number 3 and circle it, because that's how many numbers that we have to include. So you always include that number 7. So somewhere in the middle, you're going to use 7. But again, if you're listening, please write the number 3 and circle it somewhere near this example 4 so that you know that's like a note to you that you have to have 3 numbers on your graph. So 7, and then you always want to go 1 after it and then always 1 before it. So 7, and then also 6 and 8. You could spread those out if you'd like, because normally on your homework, I'm just going to give you a graph like this. So then again, you would just use your 3 dots, and so you would say something like 7, 8, and 6. So then we're going to look at our inequality. So again, we can look up at our chart to identify which way that we're going to shade. But this also, if you read this, it says A is greater than 7. So you know, because it's not or equal to, it is going to be an open circle, and I always like to draw it above. I know that some people do it right on the graph, but I think that kind of looks like a jumbled mess. So I do it above, it's an open circle, and then I'm going to, based on my chart, I know that I'm going to shade in this direction, but also you can see that based on our inequality. So A is greater than 7, so you can plug in any number to make this a true statement. So right here, if I were, instead of using A, I could use like 10. 10 is greater than 7, and I know that 10 is right here, and so that is a solution, so it checks out. That's just kind of a quick way for you to check to make sure that you have shaded in the correct direction. All right, let's go ahead and turn over our notes. All right, so in this example, it says graph the inequality. So again, we need to use those 3 numbers. So I'm always going to put my number that I need in the middle, and then I'm going to say this is -3 and this is -2. So notice this time I've just decided to skip these ones so that I have a little bit more space, yet I don't know how to correctly write my number line, so sorry about that. -5, -4, -3. So again, I have decided to skip those because, like I said, on your homework, it will just look like this, and so you will just be required to do those 3 tick marks. You always have to have 3 numbers. So again, we always look at our symbol, so I know that because it's an or equal to sign, that it is going to be a closed dot at my number, -4. And then I'm going to determine which way I want to shade it. So because B is less than or equal to, also I know that if I were to make this an arrow, I would go in this direction. And again, you can check yourself because B is less than or equal to -4. So I could just plug in like -10 is less than or equal to -4. -10 I know is way down here. So this does indeed check out. I shaded in the correct direction. All right, so you go ahead and pause the video and I want you to try example 6. All right, so in this U-try, we have -2. I know that X is greater than or equal to, meaning it is a closed dot, and I'm shading to the right. All right, so let's go ahead and look now at us taking our inequality and writing that inequality from a graph. So again, just similar to the words at the very beginning, we said X is a dot and then the number that we are using. So the number right here looks to be 2. It is an open dot, which means that I'm not going to have an or equal to sign. So it's either going to be in this direction or in this direction. Now we just kind of have to determine which direction I want to go. So because I'm going in this direction, I know that because of this right here, it is going to be an open. So also with that inequality sign pointing to the X, and then I can also plug that in. So I know 6 is a solution. So if I replace 6 with X, 6 is greater than 2, it checks out. All right, looking at the next example, again, I always start with my X. I have my big circle that I'm filling in my inequality, and I'm using the number -3 because that's where my dot is. I know it is closed, so therefore I have a line underneath. And again, now I just need to figure out, am I going in this direction or am I going in this direction? So again, because I'm shading this way, I'm just going to look right there at my inequality symbol, and I see that that arrow is pointing, so X is greater than or equal to -3. Again, plug in a number, so I could just use 0 in this case. So 0 is greater than or equal to -3. It definitely checks out. All right, go ahead and pause the video, and I want you to work example 9. All right, so hopefully on this U-try, you saw the X is less than -2. All right, so now looking at our very last examples, for the given value, we're going to state whether it's true or false. So there are 2 ways to do this. On the first way, I'm going to solve for the letter T and then identify if that solution would work. And then on example number 11, I am going to actually just plug it in from the beginning to show you that there's 2 different ways. So similar to equations, I can draw my line down this inequality sign, and I'm just going to solve out my equations, but now it's an inequality. So the opposite of a +8 is a -8. So notice here, this is when people kind of get confused. This T equals -1 is what I'm trying to see if it's a true or a false statement. So that's not part of our actual inequality. So all we have now is 2T is greater than, if I have 7, and then I'm taking away 8, I know I have -1. And so then the next step, again, to get T by itself, I want to divide both sides by 2. So T is greater than -1/2. All right, so with that, when I plug in now my -1, is -1 greater than -half? Is -1 greater than -half? Well, with negatives, remember, it's like backwards. So the bigger the negative number, the smaller it is. So is -1 bigger than -half? No, it is not. So therefore, this is a false statement. Very false. All right, moving over here now to this example 11. Like I said, you can either solve it out or you can just plug it in. So from the get-go, I'm going to replace y with this 4/3. So I have 4/3 minus 1/3 is greater than 1. So 4/3, and if I take away 1/3, I'm now at 3/3, and 3/3 is the same thing as just 1. So is 1 greater, or 1 less than 1? And that is not a true statement. So therefore, this is also false, because 1 is not less than 1, 1 is 1. So therefore, this would make it a true statement, but because we don't have that or equal to sign, therefore this is a false statement. All right, go ahead and pause, and I want you to try this last you try problem. Alrighty, so hopefully we ended up with true. And notice in the directions it says justify your answer just by showing work. That's a great justification. For this one, I just plugged in that 6. So I got 9.9 is less than or equal to 12, which is very much a true statement. All right, good luck on your problems.